afternoon. Welcome to the Programming and Design for Next Generation ISR Facilities webinar. My name is Jacqueline Barrett, and I will be available to assist with technical issues that may arise. However, WebEx is also available if you have more other technical difficulties. Their number is 1-866-229-3239, and I have put this in the chat box as well. Also, if you have trouble connecting, you can email me at jbarrett, that's JBARRETT @SAME.org. During the presentation, please submit all of your questions through the Q&A box located on the top right side of your monitor. Enter your question and then send it to all panelists. Finally, our webinar today is being recorded. Within 3 business days, you will receive an email providing a link to the presentation, and also will send the presentation slides. Once again, thank you for your participation. I will now hand it over to Pedro de Jesus. He is our moderator for today's webinar. Pedro?
Hello. Hello. Welcome to SAME's first Partner Program webinar. I am Pedro de Jesus, your moderator for the program. I am the C4 ISR Program Manager and Technology Director for CH2M. Chris and I have worked together on planning and design projects for ISR and other military facilities for more than 13 years. I am an electrical engineer and a communications systems specialist holding RCDB and DCDC credentials as well as professional engineering license. I've led design of communications, electrical, and audiovisual systems for U.S. DoD and other federal agencies, as well as projects for other national governments and critical facilities for companies such as Sprint and Ingenuity. If you are new to SAME or these webinars, I encourage you to check out the SAME website to see what other opportunities SAME has to offer. We are fortunate today to have a great speaker here to talk about this important topic. Before I introduce our speaker, I would like to spend a moment on what you can expect on today's call. ISR facilities refer to intelligence, surveillance, and reconnaissance operations. Lives truly depend on the young analysts performing missions 24/7 at these facilities. Today, you'll learn why these facilities must be human-centric and provide flexible, adaptable, and expandable space that positions the building to support missions well into the future in the face of rapid technology and mission changes. ISR facilities that are not properly programmed and designed can constrain the mission rather than efficiently and effectively support the mission and provide an environment that promotes healthy, productive performance by personnel housed in them. The webinar is scheduled to last 1 hour and will be worth 1 PDH or 1 AIA LU HSW, and that's pending approval. We invite questions as we go along. To submit questions, click on the Q&A button on the right side of the screen. We ask that you type in your question in the text box and submit the question to all presenters. I will be referee on the questions and try to queue them up in the order that they are received. We will take time to answer questions at the end of the presentation. Regardless of whether they are answered live today, we intend to provide written answers to all questions through the SAME website following the webinar. Now, to introduce today's speaker. Chris Hargraves is an AIA and lead AP O&M professional and is the Principal and Architect Program Manager with CH2M. Her experience spans all aspects of architectural practice with an emphasis on programming and planning studies for military facilities. Over the last 14 years, she has been a key consultant in the transition of the U.S. Air Force 480th ISR Buildings DCGS mission, contributing to facilities development through needs assessment studies, standards development, master planning, design, and consulting services. She has been the architect for 5 ISR operations facilities MILCON projects and led study teams in assessing many ISR buildings to develop facilities master plans and programming projections for renovations and replacement facilities. In addition to project roles, her 32 years of professional experience includes experience as a consultant and contractor too, as well as an employee of U.S. government agencies. She was also previously a federal studio principal at RSP Architects Ltd. And architect program manager for CH2M Hill at various office locations. So with that, I hand it over to Chris.
Thanks, Pedro. And thank you all for joining us today. The objectives of this session are to reveal some key features that we see as part of next generation ISR facilities, help you gain some awareness of what human-centric design considerations apply to these facilities, learn about future-proofing design approaches that are appropriate to ISR facilities, and consider priorities applicable to programming next-generation ISR facilities. Pedro mentioned that ISR refers to intelligence, surveillance, and reconnaissance facilities. We'll talk a little bit about what a next-generation ISR facility is in our definition. We'll talk about human-centric design, future-proofing of ISR facilities, and then programming and priorities, and then take any questions that you might have. So what is a next-generation ISR facility? Next-generation ISR facilities are future facilities that require state-of-the-art facilities to accommodate technology systems, the weapon systems that are used by various military missions today and well into the foreseeable future, and the building systems that support those personnel and help them deliver the mission sets. It requires a little bit of looking into the crystal ball, but there are some strategies that have helped us provide that opportunity and make ISR facility designs adaptable to well into the future, and we'll talk a little bit about some of those strategies. And ultimately, we like to think that the building functions as essentially as part of the weapon system itself. It's critical to have the right infrastructure and building systems and spaces to support the mission, and we'll talk about what that means as well. These types of facilities include a wide range of different types of intelligence gathering and research and analysis. They can house missions that relate to imagery or intelligence, signals intelligence, and other types of intelligence. Most of our experience has been related to imagery exploitation types of missions, but the relevance of best practices that I'll be talking about, while they depend on the specific mission in each facility, we feel they're probably applicable to a wide number of intel types of facilities. So next generation ISR facilities, if you ask a facility manager or one of our customers for these types of facilities, they usually refer to space, power, and cooling systems as the elements that are critical to these facilities. And that's similar to any kind of mission critical facility, data centers and other technology intensive facilities. The functionality of the facility is important in terms of the different types of spaces that are provided, and the reliability and survivability of these facilities is an imperative, as are the infrastructure elements that serve the facility and the providing adequate capacity as well as the redundancy that's usually needed. Human-centric design, of course, enables and supports the analysts and provides a healthy and sustainable facility and setting for them to do their work. And then there's the future-proofing, which is a key element, state-of-the-art systems that are flexible, adaptable, reconfigurable, and expandable will help the building to serve these types of missions well through its lifespan. I think most people who've worked on military facilities recognize that they're designed for the long haul. They're often in service for 40, 50, or many years beyond that, so future-proofing is really essential. So first of all, let's talk about some of the space aspects of those items. The qualities that support the ISR missions include the functionality, the human centricity, and future-proofing. So I'm going to touch on the functional aspects of these facilities first of all. This is one of my favorite quotes in the bubble on the slide. We shape our buildings, and thereafter we shape us. And we've definitely seen where buildings, and this isn't just ISR buildings, but a building that's not really designed to support the functions that occur within it, constrain those functions. So it's an important consideration on ISR facilities in particular because they have such a critical mission. You don't want the building to limit what they can do within it. The different types of functions can be roughly categorized into these items listed here. There's operations spaces, operations support, command and control, what I kind of refer to as the wellness and support functions for the analysts and the personnel. And then there's building systems, which are often a significant portion of these types of buildings. They can be 15 to 20% or more of the building gross area. I'm not going to go into those because they're pretty specific to each building's design, but it is an important aspect of each building. And then there's other assigned functions dependent on the specific building mission. So I'll briefly touch on each of these, what's functionally included in them, and then we'll talk a little bit about some of the strategies to make sure that you have the right functionality and types of space and qualities of space in an ISR facility. Operations, when I refer to operation spaces, those are the actual elements of the weapon system itself, the technology and software systems that actually help the analysts deliver their mission sets. Operations floors, server rooms, mission communication type spaces, briefing spaces, and mission planning spaces tend to be included in this category. By operation support, there's a host of other functions that are needed to kind of facilitate the actual operations. That can be operations managers in a building with multiple operational spaces. For example, they may kind of be the traffic cops to assign spaces and people and so forth. There's training and simulator space usually included so that people have an opportunity to ramp up as they're brought into the missions. Audio-visual equipment support spaces, a term that we've started to use, which is system setup and support. Generally, this refers to the spaces where you bring in equipment, the computers, the servers, and so forth, and set them up and provide maintenance and repairs as needed. This can also include receiving and shipping type spaces. We've seen buildings where this kind of space was missing, and because the technology changes so rapidly, we walk down the corridors and they're stacked full of boxes of equipment that's either coming into the building or leaving the building. So this is an important support function. And then the maintenance support. And by maintenance support, I refer to not only the maintenance of the weapon systems and equipment, but the maintenance of the building systems as well. Then there's command and control spaces. There may be command suites and other types of administrative offices, conference rooms, video teleconference spaces, and various types of briefing spaces. Analyst wellness and support spaces may include, we're seeing more and more counseling spaces, spaces for physicians, possibly exam rooms and spaces similar to that, showers and lockers, a lot of military facilities, well, most military bases will have some sort of fitness centers, but because these missions are often 24/7, 365 types of operations, having space for fitness equipment and then the showers and lockers so that personnel can get their physical training in has been a newer need that we've been finding. Coffee and break areas have been evolving to be an important part of these facilities, especially those where they can provide healthy food options to personnel because they have short breaks. They can't usually leave the building and run and get good food and so forth. And the coffee shops, of course, are always a popular item in any kind of building these days. And then one other item that our clients have been looking for is secure bike storage, indoor bike storage to provide some support to those personnel that have more sustainable commuting strategies. So some of the qualities of space that we find important to those ISR facilities supporting these kinds of missions include the opportunities for collaboration with coalition partners. This may be, for instance, allies of ours that want to collaborate on certain missions, but they have very specific access to certain kinds of information and not to other kinds of information that might be part of missions that are ongoing for our American services. So a separation is needed to allow for that collaboration without impinging on other full-time operations. We're also seeing that we need to provide for different classification levels of work and information that's being shared as part of the mission sets. There may be spaces needed for uncleared personnel that are just coming into the missions but can't be on an operations floor yet until their clearances come through. And then there's certain functions that whereas the main operations are typically housed in SCIFs, there's other functions that need to have access to secret level classification. So all of those have different types of requirements. One thing that we've discovered as a useful strategy, however, is to design the building kind of with a modular strategy in mind, that any one of those types of classification of space can be upgraded pretty easily if we can design that into the initial construction of the facility or the upgrades that are being made to an existing facility. Mission-specific collaboration with U.S. partner agencies is another thing that would require space that can be isolated from other missions. This might, for instance, include FEMA or National Guard components that they may not have access certainly to ongoing military operations, but there may be humanitarian missions or natural disaster response or things like that they would be brought into a facility like this. So this is a relatively newer space category that we're finding is needed for ISR facilities. And then just a few other best practices. Consider the varying types of work tasks that occur in a facility. You can see, for example, in these photos that there are people that are looking at imagery at the desktop. There are people that are looking at data walls, and then there are people that are collaborating kind of offsides from other active tasks. And all of those are important and need to be considered in laying out these spaces. Kind of related to that is designing to accommodate rapid changes in personnel. There's usually shifts in many of these buildings, especially if they're 24/7 operations. So you may have 100 people on an ops floor and then another chunk of folks coming in, maybe not fully 100, but coming in to take over certain missions during shift changes, and there may be an overlap. So the building may actually have a significant surge in population that has to be accommodated, and this may also impact things like parking as well as the throughput at the secure entrances. Operations floors, for the functional design of an operations floor, we tend to see these as being fairly large column-free spaces, and our clients want them to be as flexible as possible. So they're designed with a lot of infrastructure to allow for the cooling, the power, the communication service. We look closely at the adjacencies of the spaces nearby, the operation support type spaces. And more we're seeing that the ops floors, while the clients prefer them to be a fairly large open space, certain areas of them may need to be isolated either visually or both visually and acoustically to accommodate some of these other segregated missions that I mentioned a minute ago. Part of the operations floor design, of course, has to consider the audiovisual systems. There may be a variety of systems, and these are systems that are available now, and they'll continue to evolve through the life of the building, of course. Now they include things like a tiled data wall or knowledge wall. There may be a command bridge, an elevated area, or elevated and separated in some cases with just windows for overlooking the main ops floor. There may be interactive types of monitors or tables used for mapping evaluation. There may be whisper quiet rooms, things like that on the ops floor. So there's a lot of different systems that have to be accommodated. And ultimately, with all of this stuff, you've got to balance security, life safety, and accessibility with the operational requirements. There are a number of spaces, of course, in an ISR building that are designed to support very specific functions, but wherever possible, we try to look at spaces that are for training or conferencing, sometimes briefing, as spaces that should also be able to quickly be reconfigured to support a surge in operations tempos with very little reconfiguration. Conference and training spaces seem to lend themselves best to that, but we do watch for any opportunity to provide some flexibility in how spaces can function. And to accommodate that, the audiovisual systems need to be integral with the building design because that affects the ceiling heights, the infrastructure, the raised floor heights, the support loads, and acoustics throughout the facility. Operations floors, I mentioned before that they do tend to be column-free spaces because that affords the most flexibility in use. It also allows people to interact between the pods of different missions or activities that may be going on. We try to make sure we provide sufficient space to maintain the equipment, the weapon system equipment, as well as any building systems that can be accessed from the ops spaces. The building systems, we tend to try to keep things like VAV boxes and that sort of equipment off the ops floor, but we also think about how those systems serve the floor and can provide some flexibility in where the cooling is concentrated and so forth. We also design the infrastructure in such a way that it can not only accommodate the current loads, but that it can be expandable and adaptable to the extent possible in the future. A few additional considerations. Transitions are really important and getting more and more attention in facilities like this. Consider transitions, for example, between areas with different types of illumination. You see in the photos here that an ops floor has fairly dim lighting so that the analyst can focus on the computer monitors, but then transitioning to a normal office space with a much brighter level of illumination can be kind of hard on the eye. So we look at vestibules or corridors as strategies that can help with that transition. Another thing to look at in terms of transition is movement between the ops on-duty type spaces and functions and where people go as they move off missions and ultimately out of the building. We design the furniture systems integrally with the building design, and we try to reduce the number of typical furniture workstations. That kind of maximizes flexibility throughout the building, as well as helps the building management have a streamlined system to worry about. We standardize racks and cabinets in the server rooms as much as possible to allow for more efficient space layouts, and design for future replacements of the weapons systems and building systems as well, and make it possible to get access to these equipment elements so that people can actually do those replacements without taking operations down. ISR facilities need to be designed to support the personnel that occupy them, like any building. But when we first started looking at ISR facilities some years ago, the bigger focus was on determining what the requirements were to house the weapon systems, and how many of each type of workstation and so forth was required, and how big the workstations were, and then how to fit those into the spaces that existed if it was an existing building, and how big to plan for new buildings that had to account for X number of missions with X number of weapon systems. So the focus was really more on functionality in the early years of some of these ISR missions. But as the missions have evolved and the facilities have kind of continued to be broken in, if you will, to support the missions, we've seen a growing and deeper understanding of the role of the analysts and their health and productivity needs, which is it's a great refocus. Pedro mentioned earlier that we've worked with the 480th ISR wing headquartered at Langley Air Force Base. This is a comment from a report on some of their facilities and other aspects of their mission that was prepared by the Air Force 711th Human Performance Wing a few years ago. And they're recognizing that the 480th has really initiated some major efforts to re-envision how they perform their work and what that means with respect to facility design. So I'll touch on a few of the human-centric design elements that we've been looking at as a result of that re-envisioning effort. Some of the challenges related to personnel that are working these ISR missions include the various health issues that can range from stress and depression, anxiety, and ergonomic injuries to suicides. Some of the intel missions have seen very high rates of emotional and health issues and suicide rates increasing. So there's a big effort to try and identify ways that these can be addressed and make sure that the personnel are that their needs are addressed not only operationally but in the facilities that we look at. Some of the other challenges, of course, recruiting and retention of the young soldiers and airmen and sailors that conduct these missions. They're competing with the tech industry, and when you can see the pictures at the bottom of the page. The one on the left is a picture of Apple's headquarters, and the other one is kind of a typical ISR facility with no windows, pretty boxy. You know, where would you want to work if you're a young tech-savvy service person? And then I mentioned transition as well. So transitioning between work and personal time has increased stress for in-garrison missions. Conducting one of these missions in garrison has a unique kind of stressor to it. The personnel work the mission supporting people in theater, and then at the end of the day, they leave the building, and when I've talked to some of the young analysts, they say they go sit in their car and smoke for an hour or so until they can kind of get their head back together and, around their personal life, and then they go home and try to resume that personal life. So there's an additional stressor that people working in theater don't quite experience, and that's something that we try to think about as well. We can't provide smoking rooms in these facilities, but we do try to provide break facilities and counseling spaces and rejuvenation space, things that will help to support that transition better. So human-centric design considers a variety of different human factors: ergonomics, stress management, circadian rhythms, focus and alertness issues. When people are working long shifts, focused on pixels, that can be a challenge. I mentioned the transition issues already. Focused work versus collaborative tasks. Many times you have a demand to do both of these in the same types of space with the same types of people, and that can be a challenge, but we try to address that in a variety of ways that I'll talk about. And then there's certainly the evolving workplace environments and expectations as younger generations come into these missions and look for the same kinds of facilities that they might expect to see in other types of buildings. Internet cafes and access to Wi-Fi, the ability to use their cell phones, which are right now pretty much forbidden in this type of building. I mentioned the rejuvenation spaces or caves and commons, spaces that support different kinds of work. Ergonomics is, when we talk about human factors, ergonomics tends to be what comes to mind first. It's kind of the tip of the iceberg, though. There's certainly workstation configurations need to be adjustable, and because the needs differ for each person. They need to be customized and able to do this pretty quickly. You need to consider the impacts of those different types of configurations, however, on the overall operations floor environment. You can see on the diagram to the right, there's a standing height workstation and a seated workstation. If you're trying to see across the operations floor to the data wall, for example, and you're in a seated workstation and somebody's in front of you in a standing height workstation, that can be a problem. So this is we talk a lot about these kinds of things as we lay out furniture systems with our clients and try to zone the floors accordingly and provide the options to provide access to the AV systems in different ways, and I'll kind of mention some examples of that in a minute. Maintenance access is also important. I mentioned that, but it's an ergonomic issue. It's not just trying to make sure that people can get access to things. It's get reasonable access without incurring injuries on the maintainers. We're looking at getting servers and thick clients and thin client locations to optimize workstations. Sometimes the older workstations have been enormous because they have multiple CPUs housed beneath them, and you see this in a lot of different types of operation centers. Big workstations with shelves below that generate a lot of heat and noise from the fans and so forth. So we're looking at ways to get these away, kind of separated from the individual workstations, and then looking at other types of equipment to sort of optimize the workstation ergonomically. Acoustics is another human factors issue that we look at when we talk about a large operations floor with perhaps 80 to 100 personnel and the CPUs or thin clients, the monitors. There's a lot of noise in these spaces. So there's equipment noise that needs to be dealt with. There's highly reverberant materials in these spaces because you've got the desks and the monitors, and there's not a lot of soft surfaces to help mitigate some of the noise issues. So that's a consideration that has to be accounted for. We try to locate large HVAC ductwork outside the rooms because those generate noise potentially. We like to engage acoustical consultants to make sure that we can sort of optimize the noise and sound control issues in the design. But we also need to make sure that we are looking at ways that the workstation configuration and the acoustical attenuation qualities that we design into spaces still allow for conversation between the coworkers within the space, because that's an important part of their work as well. Visual hygiene issues that we see include things like the eye strain and alertness and focus issues that can be a result of the dim lights that you often see in operations floors. So some of these strategies there are to use a high flicker frequency lighting that is easier on the eyes and helps avoid eye strain, provide areas with daylighting and views. This, of course, has to be coordinated with security. Security folks for this kind of mission, they prefer windowless buildings many times because it's one less thing that they have to worry about. And if they do have windows, they often have to keep the blinds closed. So that creates some issues with respect to the access to daylighting and views, certainly. So our strategies include providing multiple lighting sources that provide some options where possible that they can be controlled by the individual analysts. We look at how to control glare on the work surface and the monitors from the lighting sources, and try to minimize patterns and contrast in the flooring and other surface materials. And then if we have an influence over the monitor selection, or how they're mounted on the desktops, we look at ways to make them adjustable to help avoid the eye and neck strain issues. There's been a lot of research in the last few years on circadian rhythm disruption and how healthy buildings can better enable people to maintain their circadian rhythms. When you're talking about an operations center, however, where people are working the night shift, for example, or have an absence of windows or the blinds are closed a lot of times, that can create some issues with respect to those circadian rhythms being triggered. There's a little slide here from a recent AIA convention. This is from a research effort that was, the presentation is from a research effort that's been sponsored by GSA and being conducted with Rensselaer Polytechnic Institute. And one of the things that they had listed in their presentation was all the different health impacts that are being found with respect to circadian rhythm disruption. You can see poorer sleep, which in turn results in higher stress levels, increased anxiety and depression, increased smoking, cardiovascular disease, diabetes, higher incidence of breast cancer. So this is a really important consideration, especially when you have a building that your customer says, you know, the fewer windows, the better. So consider opportunities where you can provide access to daylighting and illumination systems that can trigger those circadian rhythms. There's research that has looked at different aspects of the visual spectrum of lighting, and I think I mentioned the blue lighting. Blue lighting is often looked at now for its benefits in increasing alertness especially for shift workers, but the RPI researcher that I spoke with said that red light is probably a better solution for that, and so they're looking at the red light portion of the spectrum instead of the blue for helping to increase alertness in night shift workers because the red doesn't disrupt disrupt the circadian rhythm triggers. We also try to provide discrete access to things like counseling, medical facilities, and stress management support in these facilities. The young soldiers and airmen, for example, don't always want to walk right past the command suite on their way to a counseling office, and they like to make sure that they are getting the resources they need, and their command wants to make sure they're getting access to them, but discretion is important in how these are located within the building. We also try to provide crew support spaces, dedicated crew break areas, and I mentioned earlier the coffee bar is a well-received option, as well as places where people can obtain healthier foods and get some workout experience during the day as well. And the third aspect I'd mentioned for ISR facilities is future-proofing. Future-proofing is really kind of a facet to sustainable design. It's designing a building with the future in mind as well as the present, and designing to allow for resilience, which means a tolerance for change in function without taking the building down or impacting how personnel are conducting their work and so forth. We'll talk about a few strategies relative to future-proofing. For ISR facilities, that typically means flexible, adaptable, reconfigurable, expandable, words that we use a lot with our customers when we're talking about these kinds of facilities. An example to the right, there's a picture of a conference space with a switchable glass, or what some people refer to as snap glass. So if there's something that's some classified information that's being worked with in a space like that, you can quickly convert it to another type of use and be discreet about the the classified materials that are being used in there. That's a flexible system, adaptable system. Another example, at the bottom, there's a picture, an elevation of a building that has been designed to be modular, so that if windows need to be added in the future or removed, they are kind of in a panelized system that can allow for that reconfigurability to happen pretty quickly. The goal, of course, is to support the weapons system now well into the future, and the starting point for that is to envision the end state, look 5 to 10 years out, and consider what will happen if there's certain changes, change in operational tempo, increases or decreases, changes in technology and the concept of operations, and then look at the infrastructure. Make sure that you've got redundant and robust infrastructure at all levels, at the building level, the site level, and the base level. And then the ability to upgrade the systems as well. Some of the expansion strategies that we've utilized, this is a new building. It has the ability to expand at the end of each wing as well as off the center entrance pavilion. The strategies used include those that are listed here. We put stairwells at the end wall so they can kind of buffer the operational areas from future construction. We've got strategies in place to link corridors to future extensions. The building systems and the infrastructure were all designed to be expandable. And when the building was sited, it was sited in such a way that it will allow for growth. We did similar sort of strategies within the building. We have the areas that are smaller boxes on the top 2 diagrams show the arrows where those spaces can be expanded. In this case, it's a mission comm server space that could be about doubled in size by taking over offices that are adjacent to it. The customer didn't need quite as much server space when the building was originally built, but they could envision that in the future they might. So we have consistent floor-to-floor heights, consistent raised access floor heights throughout, and that allows virtually any part of that wing to become more data center type space in the future with very minimal reconfiguration. We also zone the building, this particular building, in such a way that all the permanent core type functions, the restrooms, the entry control facility, comm rooms, electrical rooms, things like that, elevators, all of that was centralized so that the entire wing could be reconfigured without impacting those functions. So ultimately, well-designed ISR facilities, just to kind of bring it all together, they're intended to support and promote mission effectiveness as well as personnel wellness and productivity. The diagram kind of shows where the functional human-centric design, the future-proofing strategies, and then energy assurance and resiliency, where all those come together, where all those converge, that's where you have the best opportunities for mission effectiveness to be facilitated by the building. The energy assurance I'm not going to talk about today. That's an item that Pedro is going to discuss more in a similar session next week, so I encourage you to attend that webinar as well. And as an architect, I also believe that it's important that we design buildings that provide not only functional, future-proof space and so forth, but they should be pleasant and attractive and healthy and inviting workspaces. They should be appropriate for the next generation of analysts, known for their tech-savvy, different communications and work styles, and they're more sophisticated about design. We're seeing competition, as I mentioned earlier, with the tech sector, and I think facilities that think about how their work styles can be evolving will help support recruiting and retention of great personnel, as well as to support them as they deliver their missions. And ultimately, a good workspace, an attractive and healthy building will help evoke a sense of pride, unit pride, and accomplishment of those that are working there. So let's talk a little bit about beyond design, or ultimately before the design, we feel it's really important to collaborate closely with the users on specific missions and understand their mission-specific requirements. The little excerpt on the right is from an Air Force Standard Facility Requirements book, and it has very little information for this kind of facility. It basically says contact, well, FISRA at the time, now it's the 25th Air Force, but there's very specific requirements to support each mission, but they're undefined until you start a project. So it's important to work with the users to understand what their operations are, how they maintain their equipment, how their personnel will work. And ultimately, it's important to make sure that the programming is appropriate. These are not typical buildings, next generation ISR facilities. They don't have standards. They don't have rote programming data that's available necessarily. It's important that the programming process recognize the criteria appropriate to each mission and the need for adequate site space, adequate audio-visual accommodation, and so forth. So the space, power, cooling, all of that affects the cost of a building, and you've got to make sure that you can get the right funding to support these kinds of facilities adequately. And so the innovation that's brought to bear on each design, whether it's an existing building or a new building, is key to helping support the procurement strategy as well. We think that procurement strategies will help to drive the successful outcome. And by procurement strategy, I mean design for design bid build or design build, things like that. I asked one of our clients recently about design build, and they said that doesn't work for them because they need that opportunity to have the designer really collaborate with them as they define the requirements better in the design process and as they ultimately realize the design. And they feel that design build drives more for a low-cost outcome. So I'm not necessarily saying that's the only solution. I know there's a lot of design build work that's going on in this arena, but it underscores the awareness that our customers have that the procurement strategy taken will help to drive successful outcomes. In summary, ISR personnel need to drive these missions, and the facility needs to support them to make sure that they can be effective and healthy as they do that. That's human-centric design. ISR facilities have unique requirements, and if you consider them part of the weapons system, an extension of the weapons system, if you will, and look at what those unique requirements are in a collaboration with your client, you'll have a much more successful design process. Technology and human factors must be balanced. They both are absolutely imperative to the outcome, to the operation. We need to design for future missions as well as the current mission requirements, and we need to look at how to help align programming as well as procurement with the mission to ensure a functional, reliable, and flexible building. So with that, if we've got any questions, we'll be happy to answer them.
Thank you, Chris. Yeah, we have a few questions. The first question is, how much should be programmed for a typical ISR facility, and how do they compare in cost to other military buildings?
Well, I'm not sure there's a typical ISR facility, and I can't give you a specific cost, but I would say they're easily double or triple the cost of a typical office building in our experience. So it's important to understand what all the requirements are, and when you put them together, including the redundancy for building systems and how you're going to approach things like the raised access floor systems, how you can fit these missions into existing buildings. All of those are key factors in determining what the cost will be.
Okay, thank you. Another question we have is, okay, even though IT is evolving rapidly, have you seen efforts to do more than just provide flexible building design in order to accommodate IT. For example, is there ever a joint effort between IT manufacturers and building designers to combine building envelope to meet IT needs, such as cabling, routing, server rooms, locations, cooling, etc.?
That's a good question. I haven't seen that specifically, although when we design, we work very collaboratively as a team and look for opportunities to better design the infrastructure in the building and incorporate it, but I haven't looked at it in terms of the building envelope.
Well, I can address a little bit more.
Yeah, go ahead.
I guess what we have seen DoD-wide, there has been a tendency for non-mission critical type of systems, for example, non-critical data center type of applications, go the route of using commodity type of solutions, such as modular data centers, or going to Amazon Cloud type services. For ISR, we haven't quite seen that kind of approach taken. So we haven't seen manufacturers involved early in the design, but we have seen manufacturers more involved in fit-out design efforts. Because some of our customers will actually go and you know, after the construction starts, they'll bring in the weapon system guys or defense contractors to do a follow-on fit-out design, and I have seen IT manufacturers involved there. But what we have seen, we've seen more and more ISR customers bring in heavier IT presence into the design process, and there's been a lot more collaboration with weapon system manufacturers and defense contractors to be involved in the design process, which is a positive trend, and we hope to see more and more of that. So we get better feedback from the people that are actually going to bring in IT, well, really weapon system into the building.
Yeah, I think that's a good point. There has historically been some contractual or procurement obstacles to that, but I think our customers are finding ways to move the IT design up in the pipeline of the design process, as Pedro mentioned, and that's a huge benefit.
Okay, next question. I can see my computer screen fine, and I sit near a window. Why are these type of buildings often windowless?
Well, our customers like them to be windowless because of the security constraints. They often feel that operations floors in particular function better if the light the light levels are reduced so they can really focus on the monitors. This is more for imagery exploitation, I think, than other types of intelligence missions. But they are researching different ways of using the illumination systems. I don't anticipate that ops floors necessarily will have windows in any time in the near future. They prefer those windowless, but the buildings could incorporate windows in other areas. It's just a security issue. Some security officers prefer to have glass break sensors if there's windows and cameras and so forth. So it increases the amount of issues that they see with respect to security overall. It also has some acoustical issues with respect to security, so windows can be incorporated, but you need to be thoughtful about how you do that, and ideally work with the security officer early in the design process to kind of come to an agreement on the philosophy, the design philosophy.
Okay, thank you. Actually, there's a follow-on to that other question we had. I have seen, what I've seen is the building gets designed and then a year or two later gets built and then the end user goes and buys the IT. And, if the IT had been programmed into the building design, the building might not have had full walls certain places or might not have been cable trays, et cetera, at different places. So, well, I guess I can take that one too if you want, Chris. It is one of the challenges of designing these facilities in that oftentimes, you know, the IT changes so quickly by the time you start the building and finish it and the building gets built. The technology can change quite a bit. One of the ways that some of our customers are addressing that is trying to shorten the period of the design and construction and bringing those IT folks into the process along the way. And in fact, one of our current projects that's going on, the intent is to actually install the weapons system and IT systems by the time that the building contractor has actually finished the construction. So we are seeing, you know, more of a trend to try and push this IT further, you know, further up the schedule so that you don't have that time lag 2 years later. And what that allows us to do, you know, the people that are actually going to employ the systems in the building are talking to the designers from the design process, but also with the construction contractor, and there's a recognition that there's going to be some degree of change during construction, but it's got to be a highly collaborative process from the beginning to the end, and you got to build in flexibility in the design to account for some of this. Okay, I don't know if we've run out of time. Got one last question, if you can. You mentioned that the site should be selected to allow for future expansion. What other site-related issues should be considered during selection or design?
Well, infrastructure access is certainly a big consideration. Excuse me. You need to make sure that there's a couple of different routes for power service to the site, ideally, as well as communications and water and so forth. You need to make sure that there's adequate capacity. We've had to, for example, add a substation in one project because there wasn't sufficient power capacity, so that's a site selection issue for consideration. There's for military facilities, there's the typical anti-terrorism force protection considerations, but for these kinds of facilities, you also need to look at whether there are additional protection level considerations that need to be accounted for or may need to be accounted for in the future, and design in such a way that you don't preclude those changes from happening, and that kind of needs additional site space sometimes for restricted areas or unobstructed zones and clearances around the building if the protection level is elevated. Pedro, you want to add anything to that? No? Okay. I think with that, we're done. And I want to thank everybody for your attendance, and again, encourage you to join Pedro next week for a follow-on session on engineering considerations for ISR facilities.
Okay, thank you. I want to thank our speaker, Christine Hargraves, and SAME National for all of the hard work putting this webinar together. On behalf of CH2M, I want to express our appreciation to everyone who participated today. We hope you have found this webinar valuable. Next week, I will be presenting the second webinar in this series entitled Engineering and Infrastructure for Next Generation ISR Facilities. I hope you will join next week's session to learn more about energy assurance and building systems designed for ISR facilities. After we close out the webinar, the online system will direct you to a short survey. Please take a few minutes to respond. We value your feedback as this information assists SAME in providing valuable webinars. Within 3 business days, you will receive an email which will provide a link to today's recording, a PDF of the presentation, and the Q&A responses. This information will also be uploaded to the SAME website. So this concludes our webinar, Programming and Design for Next Generation ISR Facilities. You may now disconnect. Please enjoy the rest of your day. Thank you.